Hi students. Today's video lecture is going to cover basic chemistry. So you should be watching this during week 2 of the semester, and make sure to fill out your guided notes for week 2 basic chemistry. It's indicated in the guided notes as you watch this video lecture. So this class is about biology, living things, and so we start with learning what they are made out of. So living things, right, are matter. Just as this computer that I'm working on, just as the air that I'm breathing, basically anything that has mass and takes up space is matter. And all of matter is composed out of the same substances that we refer to as elements. So we're composed of elements, the ground is composed of elements, and we're going to focus on, in this class, the elements that living things are made out of. So you probably recall the periodic table. There's like 92 or so different elements, but all of life, whether we're talking about bacteria, whether we're talking about humans, whether we're talking about plants, is mostly composed of only these 6 elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. So as I write here, those 6 elements make up 95% of our body weight, okay? And not just ours, but plants, anything. So a lot of those other elements, as you see on the periodic table, are inorganic substances, or things that are not from living organisms. Okay, so matter is composed of elements, and now atoms are the smallest part of an element that still has the properties of that element. So another way to say this is, if I had a chunk of pure carbon and I could see that chunk of carbon, and carbon has certain properties, certain characteristics, and I started cutting it into smaller and smaller pieces, the smallest piece that I could cut that chunk of carbon in it and it still be carbon is an atom. Okay, so an atom is the smallest part of an element that can be broken down. And an atom has certain structural components, so we're going to go over those next. All right, so an atom now, which is the smallest particle an element can be broken down into, has different particles that it's made up of that we refer to as subatomic particles. Sub meaning below the atom, smaller than the atom. So it has protons, neutrons, and electrons. The protons and the neutrons are housed in the nucleus, which means the center, the core of the atom. And A and B are both different ways that people represent atomic structure. I'm going to look at B right now. So the nucleus has 2 of these green circles. Those are the neutrons, and it has 2 protons. Protons have a positive P, positive charge. Neutrons have a neutral charge. All right, so each proton has a +1. So in this picture, we'd have a +2 in our nucleus. Electrons orbit around the nucleus in electron shells, and electrons have negative charge. Each one has a -1 charge. So atoms are therefore neutral because the nucleus has a +2 charge, and here the electrons have a -2 charge, so they cancel each other out. So this atom is neutral. The other things about it is that the mass of an atom is from the nucleus. The protons and the neutrons are what have mass. Electrons really have negligible mass, no mass. And I'll say that the picture in A, the difference in these 2 pictures is the electrons, right, are moving all the time. They're not really like in this tight little circle. So the picture in A is a little more realistic in that sense. And there's the protons and the in the nucleus, and there's the electrons in the electron shell. You may see elements represented in this manner, especially like on a periodic table. And we're not going to really talk a lot about mass and numbers. I do this in a very superficial manner just to give you a little exposure. So the symbol, right, is a one letter. So this is carbon. The mass number, remember, is protons and nucleus from the protons and neutrons in the nucleus. So that's 12. Atomic number is just the number of protons. And generally, because atoms are neutral, protons also equals electrons. I'm sure that was a lot and sounded like a big jumble. Don't worry too much if you didn't understand every little thing I said. Okay, so now what I want to cover is how the electrons move around the electron shells and how they fill up, because that's really important to our next topic, which is molecules. The elements that we're generally going to be talking about in biology have an atomic number being the number of protons of 20 or less. And so we can apply the following rules to basically all the elements we'll work with. And what we're going to say is that depending on the atomic number of an element, right? So carbon has the atomic number of 6, right? So it has 6 electrons. But those electrons move around those orbitals. And there's different orbitals because they can't all fit in one. And so they have different orbitals, and those orbitals fill up as we have more and more electrons. So the first energy shell, or I refer to it as orbital, can hold 2 electrons. That's all. But for example, carbon has 6 electrons. So what's going to happen next? It still has 4 electrons. They have to be somewhere. So then it goes to the next orbital. But look what I say that next. Each additional shell or orbital can hold up to 8. Up to 8. In the case of carbon, it has 2 in the first, only 4 in the second, and that already is all the electrons carbon has, right? And then this third one says each lower shell is filled first before electrons are placed in the next shell. That's why we put 2 in the first, then we go to the next one, 4 more in the next one. And so those 4 for carbon are the outer electron shell. And we refer to those as the valence electrons. So the valence electrons are the electrons in the outermost shell. And it's going to be different for different elements we're talking about. Now, carbon has 4 in the valence shell, the second shell. But how many can go in there? 8, all right? So it's kind of half full, right? It's half full. And that's going to cause a carbon atom to react in a certain way. Okay, so that's what I have here. The number of electrons in an atom's valence shell determines whether it will give up, accept, or share electrons to acquire 8 electrons in the outer shell. The goal for the atom is to have 8 electrons, 8 valence electrons, because valence electrons are the electrons in the outermost shell. The ones that have already their outermost ones full, which we refer to as noble gases, we're not going to talk about those in biology, are very stable. Okay, atoms that do not have that valence shell filled react because they want to have it filled. And I'm going to give you some examples because I'm sure that was a little confusing. So here's my example right here. Here's hydrogen. Hydrogen has an atomic number of 1. It has 1 proton in the nucleus and therefore just 1 electron. Proton positive, electron negative, they're neutral. So how many could fit into the first energy level or electron shell, 2. So that's going to cause hydrogen to actually be reactive. It's going to somehow want to obtain another electron to fill that first orbital. Carbon, right, we just talked about this, has atomic number of 6. It has 2 in the first one, that shell's filled, 4 in the second, for a total of 6. It would like to fill that outer valence electrons, to have them filled. So it'd like to have 8. Nitrogen has 2 in the first, 1, 2, 3, 4, 5 in the second. You can see the symbol N. The atomic number is 7. That's the number of protons and hence the number of electrons. 7, 2 in the first, 5 in the second. It would like to have 3 more. Oxygen, its atomic number is 8. 2 in the first, 6 in the second. It would like to have 2 more. So what do these atoms do? How do they fill that outer electron shell? They combine with other atoms. And so what they're going to do is they're going to combine with other atoms to make what are referred to as molecules. Your textbook gives you very specific definitions for compound versus molecule. I am going to simplify it and refer to it always as a molecule, and define a molecule as 2 or more atoms that are bonded together. Okay? The other term that we should know is chemical formula. So a chemical formula is something like this. This is telling us that carbon, this is the chemical formula for glucose. So it's telling us that carbon has 6 atoms of carbon. Hydrogen, there's 12 atoms of hydrogen. Oxygen, there's 6 atoms. So this is the formula for one molecule. A molecule is defined as 2 or more atoms bonded together. This is definitely more than 2 atoms because it's 6 atoms of carbon, 12 of hydrogen, 6 of oxygen. All right. Okay, so now we're going to talk about the bonds. Why do atoms combine and form bonds? To fill those valence electrons, to make that outer shell 8. All right, so covalent bonds, it's a certain type of bond. In this class, I'm not covering ionic bonds. Don't read about that. I'm not covering hydrogen bonds. I'm just covering covalent bonds. Result when 2 or more atoms share electrons so that each atom has 8 electrons in its outer shell. Okay? We can break covalent bonds into polar and nonpolar covalent bonds. In a nonpolar covalent bonds, the electrons are shared equally. And there are some examples of that, like hydrogen gas, oxygen gas, methane. And we're going to show you some pictures now. All right, so I'm showing you now how 2 atoms of hydrogen would covalently bond to form a molecule, hydrogen gas. So let's recover everything we've talked about. So hydrogen atom by itself would only have 1 electron in its outer shell. How many would it like in that first shell? 2. So it's going to join with another hydrogen atom. You see they're close together. And now those electrons, instead of just orbiting around one atom's orbital or electron shell, they're going to orbit around both. So each of these electrons is going to spend some time around this nucleus and then around this nucleus. So in a way, it's the same as each of those atoms having 2 electrons in that energy level. Does that make sense? All right. And so don't worry about this. This is the molecular formula I talked about, H2, because this is hydrogen and there's 2 atoms, and this is a molecule of hydrogen. It is a covalently bonded molecule. It's nonpolar because those electrons are shared equally. All right, carbon. If you recall, carbon had only 4 electrons, and I don't expect you to memorize that. I will always tell you that. Carbon had 4 electrons in its outer shell. How many would it like? 8. So what carbon does is that it grabs 4 hydrogen atoms that each have 1 electron in its outer shell. And if you can see now, the hydrogen is sharing its electron with the carbon atom, and the carbon atom is sharing one of its electrons with the hydrogen. So now the hydrogen has 2, and for each hydrogen, the carbon is gaining 1 more electron. 4 hydrogens, 4 more electrons that orbit around the outer electron shell, making a total of 1, 2, 3, 4, 5, 6, 7, 8. So it is satisfied. And this is the molecule methane, C1C. You don't have to write a 1, H4. Now, the last thing I want to talk about are polar covalent bonds. And I'm not going to talk about those a lot, but I think you have a couple questions on them in your Connect assignment. Oxygen has an atomic number of 8, 2 on the first orbital, 6 on the second. It would like 8 on the second, so it's going to combine with 2 hydrogen atoms, and it's going to share its electrons. The only difference with a polar covalent bond is that the oxygen atom, think of it as a hog for those electrons. It's like hogging them all. You know, if you're thinking of tug of war, the oxygen's pulling more. And so the electrons that are being shared are not being shared equally. So instead of the electron from the hydrogen and the one from the oxygen orbiting equally around both the hydrogen atom and the oxygen atom, they spend more time around the oxygen atom. And if you recall, electrons have a slight negative charge. So it causes this oxygen portion of the water molecule to be slightly negative and the 2 hydrogens to be slightly positive. So we refer to that as a polar covalent bond when the electrons are not shared equally. Thank you, and see you in the next lecture.